and welcome to the Digital CxO podcast. I'm Amanda Razani, and with me today is Mario Paniccia. He is the CEO of ANELLO Photonics. How are you?
Hi, nice to meet you, Amanda. Good to see you again. Happy New Year.
Good to see you. Yes, Happy New Year. So we have been on the show before. Can you share a little bit with our audience, though, about ANELLO and what y'all are providing and working on? Maybe a little bit about what we talked about last time, and then we can move on.
Sure. So here at ANELLO, what we've done is there's two types of gyros. There's a MEMS-based gyro that's in your phone and your watch, your earpods, that gyros measure position and rotation. And so these are billions of units a year. They're not very expensive, but they're not very accurate. And then on the high end, there's these fiber gyros, right? This is a 3D print of a fiber optic gyro. It's about $30,000, $40,000, but it's used for the high end, fighter jets, submarines, ICBMs. And what we do is the world is moving autonomous. We want more and more precision, but you can't afford the big, bulky, expensive things. So what we've done is we've created the world's smallest fiber optic gyro on a chip. This we call SiPhog, Silicon Photonics Optical Gyro. It's small, low power, fits in the palm of your hand, 3.3 volts, but it has the same precision of the fiber gyro, but it's based on integrated silicon photonics. This is the same silicon that's used for integrated circuits. So we fabricate these devices in the same factories and fabrication facilities as integrated circuits. We put this with some electronics around there, and then we have a little laser in there that shoots light into this chip. And now we can very accurately measure position or rotation. We then put that into systems. And if I put 3 of those into a cube, you can sort of see here 3. You now have a 3-axis. This is for things that fly, drones. And just to compare, this is a 3D print of an LN200. This is our X3. You can see here size, weight, area, power, right? It's a fourth the size, fifth the weight, fifth the power, same performance. And this allows you now to bring that what was previously high performance capability into smaller things and bigger markets, right? Higher volume. So obviously drones, this is a use case here. We have land vehicles. This is a unit we call GNSS INS, has GPS chips. It's a sealed unit, salt spray. We're shipping this into construction. For land vehicles, the heading matters. So while you're moving around on the ground, you're still constrained, your wheels, unless you have a flying car. We're not there yet. And so it's the heading is the key. So this has one optical gyro technology in the drive axis. So here we're doing and shipping to construction, farming, agriculture. And then we have another product that we use for robots that is similar, but if you're already indoors, there's no GPS. And this is a unit that we're shipping into construction robots and hardened things. And so this is now about being able to navigate with GPS, or more importantly, when you lose GPS, GPS constrained, GPS denied, or GPS spoofed environments. And what we have, because you have this high precision gyro, you combine that into a box with CPUs and algorithms. And we have algorithms that say, hey, we're driving, for example, and I'm starting to lose GPS, whether it's a canyon, urban canyon, downtown, barns, orchards for agriculture, mines for construction. As you start to lose GPS, what algorithm says, hey, we're losing GPS, weigh the algorithm more and more on the ANELLO technology, and now we can navigate for extended periods of time without GPS.
I can imagine this being used for mapping underground unexplored tunnels and caves, or finding people that are trapped in, tunnels and caves with putting this into little drones.
Yes, and so what we're doing is we started off as an industrial application, construction, farming. Then there's a bunch of interest that's happening with the DoD. So if you're in conflict areas in Ukraine or Israel today, all the GPS is jammed or spoofed. If you take your phone in Israel today, it sends you to Beirut, right? It's all being jammed and spoofed. And then there's all these other use cases that your indoor buildings, right? We're talking about a handheld unit for soldiers or emergency people that go into buildings that you can't find. You gave a perfect use case, is that whether it's underground or underwater, 6 feet underwater, there's no GPS. You can start going into tunnels. whether it's search and rescue or other things you want to navigate. So we brought this capability now that we can navigate extended periods of time, like we're talking 30, 60 minutes of navigation at a price points that you previously couldn't think of, and form factors. So there's a perfect example. And what really excites me when I do these interviews or when we talk to customers is as we announce these advances, and I'll talk about a new product we just announced, people and customers come to us and say, hey, we have this use case, right? An example, we have robots that we put into tunnels and we want to know where in certain places in the tunnel. And if you have a tunnel that's dark, that looks the same, cameras don't help. LiDAR doesn't help, right? Because the image is the same. There's no features. So how do we know where we're going in terms of position? How do you know where you start? And so these are use cases that we're finding, all enabled by this, wonderful thing which we call SciFog, which was this breakthrough that we developed that this team here has developed over the last couple of years.
Fantastic. So now tell me a little bit about the new product.
Okay, so I said what we had before, we have stuff for land, right? This is our vehicles we're shipping. Robots, these are also somewhat land. These are robots on the ground. Air, which we launched last year. This is the X3 product, which is predominantly for drones and things that fly. And now we just launched a product at CES, which we call our maritime product. So this is now for things that are above water. Think about this, you're bouncing around and there's this new activity of USVs, unmanned surface vessels. That seems to be a very high interest now. That's the same thing. If you're an unmanned vessel and on the ocean, cameras don't help you, right? All looks the same. You can go 360 degrees. You can use LiDAR. Maybe you can use the stars. What we've done here is we've taken our SciFog, put 3 of these in here. So it's the same concept as the cube. But in addition, we've created a navigation system. So this has 2 GPS chips where we actually have GPS. It's a sealed unit. We have a navigation system and software in here. And this now, it's also watertight and sealed. So now we can actually navigate on the water. We have algorithms that take into account currents and drifts, but also allows, the reason the 3-axis is depending on the speed of the boat that you're using. There's some of the smaller boats that go 2 to 4 knots. There's the bigger boats that go 15 to 20 knots. You're bouncing around, but now we can operate and navigate on the water or underwater with ANELLO's SciFog technology and operating in GPS denied or contested or spoofed environments.
Fantastic. So can you give any examples of real world use cases this is already being used in?
Yeah, so we're just launched the product. We'll have samples. There's quite a bit of interest. We're launching engineering. We have test boxes that we've shipped that customers have been testing with. And then we're launching this product, ramping up in Q2 with early engineering samples and then full production in the fall. The interest level is quite high, but we've taken our technology, for example, just recently at West 25, which is an event was put on in San Diego, I think January 27th to January 28th. This was in conjunction with a partnership with Saab, S-A-A-B. If your readers go and look up on our LinkedIn posts at ANELLO Photonics, or if you look on our website, or if you go to a Saab, this is in partnership with SCAPA, which is their innovation group. We put our technology on their boat. This was then sent out on, people were watching real time. We sent the boat out, many, many miles out on the ocean from San Diego, turned off the GPS, and then we navigated back in based solely on ANELLO. And we were talking, I think, 30 or so miles of navigation, or kilometers, I think I should say, with less than 1% error. When we came back into the dock, we sort of measured how far we were off with the turning on and off GPS. Now, in San Diego, the testing was done by just disconnecting the antennas, right? We're not in a contested environment. The same technology in partnership with Naval X and Task Force 59. This is a Navy, Task Force 59 is the innovation unit of the Navy that's out in Bahrain, out in the Middle East. Our technology was flown out there, was then flown to Jordan. And then we had a partnership with CSATs where they have a UUV, unmanned surface vessel, USV, sorry. And it was just driven up to the tip of Israel. And the Navy that was following behind it, people's phones we could tell when they were being spoofed, we detected the spoofing. So spoofing is when you can still get, there's two things. Jamming is when you lose satellite signal, and you can sort of tell that. You can tell by the number of signals, the number of satellites, the weakness. Spoofing is you get GPS signal, but you don't know if it's real or not, good or not. And so what we can do here, because we have real-time information, we compare every 10 milliseconds, what is the position that ANELLO says, and what is the position that GPS says. And for example, in this case here, we were navigating and we were getting close to Israel, and the spoofing detected that all of a sudden GPS says you're in Aqaba, Jordan airport, or I think Aqaba is the base. You were at the Ahmad airport, which was 300 kilometers away. We immediately detected it. We said, hey, we're being spoofed, poured over to ANELLO, and then we navigated. It was just some testing that was done by Task Force 59. And there's an example in a real environment that our technology has been tested, and we navigate solely based on ANELLO. So it's quite exciting, and there's a few more customers that are doing testing that are not public. But we now have land, which we've been, as a product we shipped over a year and a half ago. We introduced the 3-axis product specifically for drones, and we have lots of customers testing. Unfortunately, lots of customers aren't public. And then we just launched a maritime product that is a combination of testing we've done with customers, both in field trials with Naval X, with other customers out in San Diego, on the East Coast and Rhode Island. And then some of this is actually being shipped over the next quarter. We have about 6 or 7 pretty big customers testing this in field trials, and then looking at ramping that into production in the summer and then ramping through the fall. So quite exciting, again.
Yes.
All based on this little thing called SiPhOG, Silicon Photonics Optical Gyro.
Absolutely. It sounds like your technology is making a large impact around the world.
Yes, and I think, as you said earlier, what's really exciting is, if you think about it, we thought about maritime a year ago. There was a bunch of interest over the summer. People came to us and we said, hey, we can build something. We built a test box first that took a combination of the X3, a discrete board for GPS, a discrete board for our navigation software. And then as that evolved, where there was interest, we ended up building a real product. And this is, like I said earlier, the real excitement of working with customers, putting our technology onto real use cases, and then together with the customer, building a product that's optimized for the use case. And I think from the schedule I just showed you, also gives you a sense of how fast and nimble we are, how we're really customer focused. And I urge any of your customers that are listening, if you have new use cases or new applications, I think between these 3 products or derivatives, we can find how we can quickly adapt our technology. Maybe it's tweaking the algorithms, or maybe, obviously every boat is different, every USB is different, every land vehicle, but 90% of it is the same. And then we can work with the customer to tweak the algorithms. And also these are designed to be very easy to install. 15, 20 minutes, put it in. They're standard interfaces. There's no proprietary interfaces. So we're trying to make this as easy to use, easy to install, and then take it out to the mass market.
So you can custom build for a client.
If there's a business case that makes sense, absolutely, right? And we have 1 or 2 projects that are slightly taking our existing product, and then we do some custom stuff for customers. Yes.
So what's next? Do you have anything in the works for the future? Is there any reason you would try to get even smaller for any reason?
Yeah, I mean, it's sort of, the first thing is just, we're ramping up. We just raised a funding round, and we're ramping up our existing product portfolio and bringing this new customer on, the new product line, and then ramping that into production. So there's a lot of stuff happening here. But if you want to look forward, we are here in Silicon Valley. It's not the Wizard of Oz in Kansas or something, but this is unfortunately the beat we live on. This is the state of the art today. This is a 3D printer of an LN200. This is ANELLO's X3, which we just launched. And I think you set me up, but this is our next generation, right?
Oh, wow.
We're talking
So,
about
yes.
shrinking the X3 to even smaller. So this is something that's in our roadmap. It's not something we're focused on today, but this is something that we've had from customers of how do we scale it. And this is something probably in the next 3+ years. We have a roadmap that we continue, as you said, we're going to continue to reduce power, we're going to continue to reduce size. And as you shrink those, you end up with something. And by the way, we don't trade off on performance. So this is talking about something 1 inch square from a 2x2, 8 times smaller, fifth, maybe half, a third the power, same performance. So what this does is opens up new applications, right? Things you want the same precision, but maybe you want on consumer drones, or maybe you want it on, handheld and personal people that can carry it, or other things. And so as you go smaller, you keep the same performance, but it opens up volume markets. And this eventually we'll keep integrating and integrating. Eventually we're gonna make it small enough that we'll put it on every phone, on every watch, and then you can track everybody anytime, any place. Not track, but you can use it to navigate with everything you do with the same precision, whether you're in contested, GPS, denied or not environments.
All right, great. So if someone wanted to reach out to you, where would they go? Can you give the web address?
Yeah, so we can go to www.anello, ANELLO, photonics.com, all one word, anellophotonics.com. There's a link there for info. You can download the spec sheets, get on our mailing list. There's also a pull down for mailing list. And then if you have any questions or applications, we look at that every day on the info page. And then we usually send it off to our applications engineer, depending on the topic. And someone will get back to you, and look forward to hearing from you. And more importantly, look forward to seeing how ANELLO can solve your navigation solutions.
All right, great. Well, thank you so much for coming on the show and sharing all about these products.
Well, first of all, thank you, Amanda, for having us back on, and look forward to hearing more from you. And in the future, we'll keep you updated when new stuff comes out. But I look forward to talking to your viewers and your customers and our future customers. How's that?
And thanks to our audience. Stay tuned. There's more.